Hi everyone, this session is to talk about bring your own custom models and containers with Amazon SageMaker. But why is this so important? So far, as a reminder, we already spoke and covered those SageMaker built-in algorithms. Also, it's worth mentioning that there is the option to customize. To use some of the frameworks internally, like let's say you are doing some deep learning with TensorFlow, MXNet, Pytorch, and you wanted to leverage those containers that are provided out of the box by AWS. So this is the process what we usually call discrete mode, right? I'm going to be providing some of the examples, but of course there are opportunities or there are uh, projects or some needs that you need to do more because of a specific algorithm or a specific business logic or a specific customization that you need that is not provided out of the box. That's the things I wanted to talk about today. So first things first, just wanted to make a point here because when talking about containers, uh, I understand this is very important because you guys at some point in your machine learning development process, you're gonna kind of hit one of these barriers or hurdles, if you will. So sometimes you are experimenting, you have too many variations of your training script to run, and you are kind of bottlenecked by your single machine, right? And some of the times you are running your training on large models with a large data set, and it's not feasible to run on a single machine and get results in a reasonable amount of time. And that's aligned with the things uh, Sean just spoke and I spoke the other day. We distributed with having clusters for having parallelism and things like that to kind of address these issues, right? So these are the things that we have to have in mind. And these are the two common reasons why you may want to learn machine learning on a cluster, right? That's a point. Kind of the way to tackle this, I would say maybe first of all, you can run every model independently and synchronously on a cluster of computers, right? And for the second that I just described, you can pretty much distribute a single model on a cluster and train it faster, right? This is things that we came across often, right? But both these solutions require that you be able to successfully and consistently reproduce your development training setup on a cluster. And that's where we are kind of having challenges and issues because the cluster could be running in different operating systems, different kernels. We have different GPUs. And one can say, for example, oh, hey, look, I have different Python environments that could be uh, managed by those Conda environments, which, by the way, is going to be one of the exercises. Not sure if you had some of you, I noticed, have the opportunity to kind of finish one of the labs, and congratulations to you, by the way. But we're going to kind of create a lab where we're going to be tackling with different versions of an existing training model, or a model that was trained outside SageMaker with Pytorch, and then we're going to be bringing that internally only for inference, right? So I'm going to teach you about this. But the point here is that there are multiple drivers, multiple frameworks, as we can see here, right? So the point is, how many times? So we have containers to address all of these needs, right? So we have different frameworks, CPU, GPUs, kernels, and the point is, some of the concerns that we usually see when we are developing is that, for example, is my code taking advantage of all available resources, CPUs and GPUs? Uh, do I kind of have all the right libraries and with the right versions? Because if you don't have that, you're gonna kind of run into conflicts and you're gonna spend your precious time to kind of fix and imagine managing things that are not the core of and the beauty of the machine learning, right? So you're gonna be spending time with things that are not directly related to machine learning, if you will, right? So that's the thing, and that's the beauty of having this containers set up with all the frameworks that were tested by AWS, and you can just leverage according to your project needs. So that's the kind of the things we wanted to emphasize here. And of course, the process is very straightforward, and basically they are lightweight, and you have everything you need within a container and in a repository available within Amazon ECR, and then you can just pull and use it as per your convenience. That's one of the things we try to do to make for the sake of easiness and for the sake of time. So you can just go to it's kind of a marketplace where you're gonna pick up the things, but don't be confused with the AWS marketplace. It's just a way where you pick up the things you want and you use to speed up your development environment setup process, right? And of course, by recognize all these needs that I just mentioned, we made available these deep learning containers that one individual can run uh, on different platforms. You can just pick up those deep learning containers and spin up in a EC2 instance or ECS or EKS or even Amazon SageMaker. And speaking of that, we're going to have I'm going to walk you guys through in a dedicated session in a lab where I'm going to be setting up these deep learning containers for all of these different environments for using EKS as the orchestrator or even using ECS as well. I'm going to teach you and provide you with uh, all the different options we might have. And this is also important to get, of course, I would say that 99% of the time you're going to be recommending SageMaker because uh, it's very straightforward. It's a platform that covers the end-to-end process, but it's important to understand the other options as well, because usually for a specific opportunity you can leverage that integrated with VKS. So we have seen more and more customers demanding environments with Kubernetes, and they are relying on that uh, for creating even their pipeline and their process for uh, machine learning. And we have also Kubeflow that can be an answer to automate that, and we're gonna have a specific dedicated session on this point as well, just so we know. And this is a repository with all the versions, as you guys can see here. Let's say I wanted to work with TensorFlow 2.3.1, and that's going to be targeted for training and optimized for with Horvath to run with GPU, and the Python version is 3.7. So we have specific versions that covers all the different flavors, if you will, with different drivers and different things. And basically, you gotta go to this website and just explore the opportunities. And just wanted to emphasize again, we are going to have a dedicated lab to focus on this Monday, where I'm gonna be walking you guys through all the different perspectives and alternatives to kind of play with these different flavors and different frameworks we have for deep learning. Just so we just so we know. And this is a very straightforward slide where you can pretty much use that. And and this is important to understand because uh, we have something that is the SageMaker training toolkit. there is a library already installed in all of these AWS deep learning containers. So that's why we can integrate it very straightforward with SageMaker, and that the process is transparent to the developers and users uh, leveraging these containers. And here is the machine learning setup on AWS today, right? One individual can just spin up an EC2 instance with GPUs and download that and just pull that image from the ECR and then start training and doing inference with their model on an EC2 instance of their need. That's a way to do that. But we wanted to focus, of course, as I mentioned to you, we wanted to focus at this point on the options with SageMaker because one of the labs today we are going to be covering all of these two options, right? So as you guys we just spoke, we have several algorithms that are built in. This is not the purpose of this session because Sean has covered all of them uh, very well. But I wanted to provide more details on these two, the one in the middle and the one in the right, right? The one in the middle is known as the discrete mode, where basically you have the opportunity to bring your own data and you can take advantage of this, all of the frameworks that are available in SDKs integrated with SageMaker. The only thing you gotta do is to provide it with your training script. And on the right side, we have the custom containers where you can bring your own data and also bring your own container, which means that you're gonna have to implement your Docker file, and you're gonna be having to implement several interfaces required to train and to do and to serve requests for SageMaker. And basically you have a skeleton of the process and the things you need to implement and which functions you need to implement by following the like a recipe to have your custom container publish it accordingly in a way that SageMaker can understand it and can invoke as required for either a training or to do some inferences, right? So let me start with the bring your own script. So it is a high level workflow, right? So the point is, of course, you can spin up a Jupyter notebook or SageMaker Studio, but you can also develop on your own machine as long as you have the Amazon SageMaker SDK. Uh, all you have to do is to bring your training script, and that's it. Which means you can do some local testing with your model, which is really good, especially for developers, right? So in this fictitious scenario, let's just assume that you have a TensorFlow training script, as you can see there, and you wanted to train, and you do this at scale, right? And the first with the SageMaker SDK, you gotta specify the estimator, as you can see there, right? So this is the estimator, and then you specify the Python script, as you can see here. This is the Python script, okay? And you just need to specify the Python script, and assuming this is a TensorFlow script, you specify the source directory with all the dependencies, as you can see there. So everything is there. And then the interesting part here is that all you have to do is to tell SageMaker how many instances you wanted to run your training and what the type of instance it is, right? So, and that's it. And you are all set. So you gotta bring your code files, You're going to encapsulate and you're going to wrap up this, and then you pretty much are going to train your models against all of the instances you described. And then the output of these training models is going to be made available within an S3 bucket. Okay, so this is all the some of the steps. So pretty much you need to point to the container of choice, and then write your model as a bundle of files, and there are several examples out there. You need to specify the entry point, and if you have a specific, also on top of that, if you have a specific extra libraries, you can use the requirements TXE text file, right, to include those extra libraries, and then last use the web server for inference, and that's it. You don't need to be considering anything else. Everything is provided out of the box. And so here's what the process look like. So we have several images, right? MXNet, Tensorflow, scikit-learn, Pytorch, Container, and the huge is the list is even bigger. And you determine which instances, and then the next step is pretty much to run the estimator feed, and then you're gonna train your model. And of course, one can say, hey, look, how I'm supposed to do with the hyperparameters. So you basically need to train change your script to add those hyperparameters according to your need, right? As you can see here in this screenshot. So basically, what the hyperparameters are passed to your script as arguments and can be retrieved with a function in case you need to explore those things. What happens is at the end of the day, you just need to upload data to S3. The training data is uploaded to that training data, and the validation is uploaded to a different bucket. And when the process finished, and this is one example with Pytorch, right? So let's say we have an internal disk, an EBS volume with training data, validation data. Then we'll be using a Pytorch image, just pulling that Docker container from the ECR. Of course, you're gonna have the Sagemaker training toolkit available. And the things you need to think about is that you need to determine what are the channel training, validation, the model directory, and the output. That's the only things you gotta think about, and that translates into this slash opt slash ml, and that's it. And once you have your training script, this is one for Pytorch. I was explaining about the TensorFlow. The process is the same. No matter if you are working with Pytorch or MXNet, the only thing you need to do is pretty much focus on this. These are the environment variables that you need to understand, and you just need to send those hyperparameters as I explained it. And that Python script is going to read information from those environment variables and need to kind of tweak your model to access and change that data. And once you train your model, you're going to have your model artifact, and that's going to be published into S3, and that's it. Your process is able to run some inference in case you need to do that. This is the one I just finished to the explanation about the one in the middle that is known as the script mode, and of course that's why the only thing we need to provide is a script, depending on the framework you're guys gonna be using. But there are some opportunities or some project requirements that forces a developer or a solutions architect to or a data science, you include some additional libraries for a specific algorithm or to do some massage in your data or to do something different that is not provided out of the box, right? And the process is kind of pretty much the same. So, but the thing here is that you need to have your Docker build file, Docker builder, right? I'm gonna teach you during the lab. Then you're gonna need to push your container to ECR, and then the only thing you're gonna need to uh, reference that with your estimator when you're starting using the Sagemaker SDK, and that's it. You don't need anything else. It's very straightforward. The process is very straightforward. So the first thing, you gotta write your model, right? Point your model within your within your Docker file. I'm gonna explain in a bit. You need to register your container on ECR. Point your container to address the ECR URL, and you gotta implement some of the functions required for SageMaker when it's gonna kicking off your container for either training or inference. You gotta need to implement those. And remember, the process is very straightforward as the others, right? So if you remember the previous slide when I talking about discrete mode, the process is pretty much the same, right? So the only difference is that in that case, rather than relying on an existing image, you're gonna have your own image that you push it into ECR, and then you're gonna have to pull that and reference that with the estimator, and that's it. You're all set. The only thing gotta do is to run the function feed, and then you can train your model. One additional thing that's worth mentioning here, when it comes to bringing your own container, you can have one container for training and another container for inference, or you can have a single container that manages both training and inference at the same time. So it's pretty much up to you to depending on the way you want to manage. And there are opportunities which by the way is gonna be the lab when I'm gonna walk you guys through, and you're gonna be running with the Pytorch, where sometimes customers have trained the model outside SageMaker, and they provide with the assets that are by following standards like Pico, which provides object serialization training model, and then they provide this. Pretty much, you need to upload those artifacts to S3 and have these references within the functions you need to implement to serve inference requests. I'm going to explain all the details, but just so you know, take a look here. You have a work directory right here. And what happens under cover is that they have Flask as the Python framework, right? And they have a proxy using Nginx. And the only thing, and also they have the web server uh, for to serve those Python requests, right? And the only thing you gotta do is to change the predictor Python script to serve those requests, right? Everything should be part of your image. I'm gonna explain to you in the details in a bit. But the most important thing is to understand we have built-in algorithms, we have the opportunity to use existing frameworks like TensorFlow, Pytorch, and many others, and just provide the script for to use with to train the model, or you can bring your own container and your own data, right? And this is the kind of the overall structure for the directory. Within your model, you have to provide your training code, but that's going to be script files. The second step, you should have an input directory where you're going to be placing the hyperparameters. But of course, one can say, hey, how am I supposed to use that? Uh, this is something that Sagemaker is going to be managing automatically and transparently to you. So basically, you're going to need to call the estimator and pass those hyperparameters. And Sagemaker is going to spin up a container, run the training or the inference, and then after all, it's gonna kill and it's gonna kill that container after it finishes their job. The third step is you need to provide a training data. It's gonna be connected here depending on the channel you're using, and your code is gonna be creating the model and provided this into that specific directory. And just remember the final step. Final model is provided within the opt ML model. That's going to be saved to S3. That's going to be managed and done automatically by SageMaker at the end of the training session before the container is destroyed. So just a few observations here. We have Discrete Mode, bring your own Docker container, and you have also the machine marketplace. There are pros and cons for each of the one. For example, bring your own container is the most flexible, but it was more time consuming because you need to, kind of work on the stuff that needs to be provided according to the standard required in the documentation by SageMaker to be able to call those containers. The script mode is quickly, of course, you can just pick up the framework you need and just hit the ground running. But there are, even though there are a lot of options, there are some there are a few times where you're gonna need to use something specific, and that eventually you're gonna need to bring your own container. But the point is, uh, SageMaker itself is very flexible. We have lots of opportunities and just need to pick up the one that is more appropriated for your customer needs, right? So this is kind of the takeaways and the things I wanted to emphasize here. And remember also we have those deep learning containers, and you can use that not only with SageMaker, but we can use with EKS, Kubernetes, ECS, and EC2, and take advantage of specific GPUs just in case, right? So just wanted to wrap up here. That was a very straightforward session. If you guys have any questions, just please post that to the Slack channel, and we will be more than happy to provide answers and to provide tips and recommendations around this. And also remember the one of the first lab we're going to be running today. We're going to dive deep into this bring your own container by using a Pytorch container, and we are going to be kind of tweaking and customize that so that you guys can understand what the process look like. Okay, I think that's it for now. And hopefully you guys have enjoyed the session. See you next time. Bye.